This is the mastery project for Unit 5 FRQ1. For part A is asking us to draw the free body diagram on the pulley. And so I drew force of gravity pointing downwards, the normal force pointing upwards because there's a normal force acting exerted because of the axis in the middle. So I got 1 point for this, but then I lost a point because I drew the torque instead of drawing the force of just the string, or of the string. So I lost a point for this. So I got 1 out of 2 because in order to get 2 out of 2, I just need to draw the force of the string and not the radius. Since I drew the radius, I drew the torque instead. For part 2 of part A, it is asking us to derive, using this Newton's second law in rotational form, derive an expression for the tangential acceleration of a point located on the outer edge of the pulley. And I started with Newton's second law in rotational form, which is instead of F equals ma is torque equals I times alpha, which I got a point for starting with Newton's second law in rotational form. And I used multi-step derivation, as you can see here. I got a point for substituting R times F sub S into the torque, because that is where the torque is. And I got a point for substituting here 1/3 mr squared, which it was given to us for the moment of inertia. And then I got a point for getting the final answer, because I just so alpha is just equal to a over r, and then I just solved for a, which will equal to 3 times f sub s over m. So I got my last point for here. And then I lost a point because I didn't indicate that, because I didn't combine a correct relationship between the tangential and angular acceleration with an equation that expresses or is derived from Newton's second law in rotational form, because the angular acceleration, or the tangential acceleration, is equal to r times alpha. So if you, as you see here, if you just plug in, you're supposed to plug in a sub t, and you will get the same one from here. So this should have been a sub t, and this should have been a sub t, and you'll get still the same answer, 3 times f sub s over m. So for this, I got 4 out of 5 points. And for the last problem, it's telling us that weight is attached and is equal to the force of the string. So instead of this, there's a weight, and this is, the weight is still equal to s sub s, and it's asking us to indicate if the angular acceleration of the first one is less than, greater than, or equal to than the second one. So I said that the angular acceleration would be less than, because since there's a weight attached, the moment of inertia is higher, and since it told us that it is still equal to the force of the string, same as here. This means that the torque is still the same, and higher moment of inertia with the same torque means that that the angular acceleration will be lower, because it has higher resistance to rotational motion. So I got 1 point because I indicated it would be less than, and I also got 1 point because I said that that higher moment of inertia means that with the same torque means that the angular acceleration will be lower. But I lost a point because I didn't indicate that the force of the string will be, the force of the string for the second will be less than the force of the string for the first, because it told us that this is accelerating downwards, the block is accelerating downward. So if the block is accelerating downward, that means the force of the string pointing upwards has to be the same. So I got 2 out of 3 for this. So in total I got 7 out of 10 for Unit 5 Everq1.